DocSvey, primarily designed to be used by doctors and other medical researchers, provide a secure platform to create and implement medical surveys and records, like the popular SF36 questionnaire, while also making those surveys and their results publicly available. DocSvey aims to earn trust by ensuring integrity of survey data and produced results by utilizing blockchain technology, also making data available to all our users at all times. By using data collected by our users, we aim to calculate a much greater result for every survey, which will be helpful for doctors and researchers, especially those unable to draw a high sample size. On the left, you can see a screen used by Angad Singh Kataria. The center, the screen is being used by Isha Gupta. On the right, the screen is used by Rishabh Bhatia. Now Angad will guide us with the registration and launching of our app.
The first step in the registration process includes the user creating an account within our app. So the next step involves the user selecting his profile image. So this can be done either through his camera or through his own gallery. So after selecting the image, the user then sets his username. In this case, I'll be setting my own name. Then after clicking on the save account settings, this saves the profile image and the username. What it also does is it creates a twisted Edward curve based key pair, which the user can then use to sign transactions within his own blockchain. So this is the home screen of our app. We have used a vertical carousel, which allows users to easily navigate through different sections of our app. There's also a navigation drawer, which also helps in ease of access. One of the main goals of our app is to allow users to give a platform to doctors to create and take surveys of their patients. So the creation of surveys can either be handled through within our system UI. So the user sets his name, category, description. Then the user adds questions to his survey. So then you can add using this winner, you can add options and their respective weightages to these questions. There's also an option for users to edit their own survey list. So here you can see you can remove options by clicking on them, and questions can be removed by long pressing on these questions from within this expandable list view. Then you can add logic to the survey based on the questions which are being included in the survey. For example, the user's questionnaire, for example, contains 2 questions. You can add a logic to calculate the average of his questionnaire of these 2 questions. You can add this logic. Then you can also add any other custom logic, like question 2 into whatever value you want. Similarly, the list can be edited by clicking on each of these. Clicking on the logic, you can remove this logic. So this was the survey creation part. So for example, we created these few surveys. These are all global surveys which are available to all users within the app and have been created through different user accounts. So my survey section would consist of surveys created by this specific user. So there's also for creating surveys, we also add a machine learning based system. Here you can add a specific, you can add an image based on, you can add surveys, you can create surveys by entering images, feeding in images containing containing data regarding the surveys. So, for example, we created a certain template for our surveys. So, consider this SF36 image for containing SF36 data. So, here you can see that it contains a first the header contains a name. There's a category and there's a description, survey logic, and then finally the questionnaire. If, for example, I feed this image into the survey. Here you can see it automatically fills these details. Similarly, you can keep on adding questions. Like, for example, here these two questions. So adding these questions then get added to the list. You can then change the survey name to, let's say, for example, here my survey, indicating survey created by this user. On submission, you can see that this survey is then added to my surveys created by this user. And then it is also added to all surveys, which will be accessible to all the users of our app. So here, what happens is we have also given users the ability to take the survey of his patients. This can either be done through our UI, or we can generate a PDF. It can then be filled by the user and then submitted to be read by our machine learning based system. Within the system UI based system, the user either has the option to take the photo of the patient either from the system, from his own file system, or through the camera. Let's say we take the screen, we add a screenshot, we add a image of the patient from our gallery, enter the patient name, and then finally select the options. So on submission, what happens is this creates a new Genesis block for the blockchain. The data of the user, if the patient we provided, acts as the asset data within the block. Also, the block is then when a new block when created contains this specific asset data and an asset ID and also a block ID, and this block is then signed with the public and private key of the user which is stored locally and then stored within the within our server. So this data is then used to this data is then visible within the results section of our app. The my results portion provides data about the specific survey you took about for the specific the my results survey actually provides the statistical data of the surveys the user has taken. So it provides the details regarding the statistical data regarding each of the logic he specified within that survey. Similarly, the all results section contains data regarding the sample of all of the doctors, all of the patients who have given the SF36 survey or any other survey within our entire app. So any number of doctors who perform the SF36 survey on any number of patients, it then provides a generalized result with a large sample size within our results portion section, within our all results section. The my results section only provides data regarding the doctor's small sample size which he has, which we would have access to. Similarly, the my patient section provides access to the patients the doctor has to the patients the doctor has taken the survey of. So this data is only accessible to the doctor himself, the doctor who conducted the survey, and cannot be shared, and can only be shared through our blockchain based system. So within the app, we also provided the user to feed in data, take a survey through a machine learning based system. So you select the top right button, and then you feed in an image of the user data. So here is an example of the data which we've already filled in regarding for the SF36 survey. So this data has already been filled. So you can add this data feed this data to our app, and it will automatically fill the survey details accordingly. So this was one example of creating and taking surveys within our app. Next, within the My Patients section, what we've given the user an option is for sharing this patient's survey details to other users, but only with permission from the creator of the data. So in this case, the creator of the data is the current account. So current account, and when the data is shared, what would happen is a new transaction is created with the same asset data, but it would require the signature, public and private key signatures of the original creator of this data. So in this case, the doctor who conducted the survey. So any data shared would require the permission of the original user who created that data. So in this case, let's say we want to share this data to Isha Gupta. So what this did was create a request, a transaction, which since this user is the sender and also the creator, it automatically got signed with the public private key of the current user. So what this does is it this then transfers the data the patient details from my account to Isha Gupta's account, which is then accessible through her account, which is shown in the middle. Now the same way, if let's say Isha tries to share this data to Rishabh, whose screen is on the right. So for sharing this record to Rishabh, for sharing this patient details to Rishabh, I will receive a request request for the transaction to be validated, and only then will this transaction be accepted into the blockchain, and then this data will be visible to Rishabh Bhatia, whose screen is on the right. Let's say accepted. So in Rishabh's results section, and in the My Patients section, this data is now available and has been transferred successfully from me to Isha to then Rishabh, which in the backend it takes place through validation from the original user and transactions which are then added on validation to the blockchain. So this way, for each patient record created, there is a unique blockchain created which is used to then transfer asset data within the added transaction blocks. In this case, it would be each of the users of our app. So what also is we have added is is an ability for users to create medical records. These are general medical records, which could include blood profiles or general medical diagnosis. So let's say we had create a new medical record for a user. So what this does is it also is similar to how the patient data works. What it does is creates a genesis block for a new blockchain, a unique blockchain with the which would have the block signed with by the public and private key of the current user. So let's say we add some data to the list, and using our UI we fill this data. On submitting this data, on submitting the form, a new record is created. A new record is created, and this record can then be viewed in the record section of that page of our app. So this record can then be shared through to, for example, let's share it to Isha Gupta, who can then view it in a record section. And since this record is sent by by the creator of this record himself, so it's automatically signed. And similarly, this can then be transferred to Rishabh Bhatia on the right, and I receive a transfer request, which needs to be validated so that it can be added to the blockchain. And it then becomes visible to Rishabh Bhatia, and who can view the record and this data is then available and viewable to Rishabh's account. So in the backend, also we are also maintaining this general medical history of the user. So this is maintained in a separate cloud within our cloud, and that cloud and the data's ID within the cloud is then used to create a new block within a new unique genesis block within our BigchainDB database. So since we stored it in the cloud, since their data would be dynamically changing every time a new record or new survey is added for that specific patient, so that data can then be transferred similarly through a mediator account, through an administrator account, similarly to how the American Health Association provides electronically stored medical records for citizens for its country. We also similarly try to implement a system for medical history within our own app. So the mediator account can then be requested for this data, which can then be sent to any doctor only on approval. We also added a communication app. So here we can chat with different users within our app. Let's say I talk to Isha Gupta about the tests, about the SF30, about the, let's say, test survey, which we have created. So while this chat is maintained, what we also are doing what is also being checked in the backend is that the popularity of the test survey increases based on the how it is whenever it is used or mentioned within our app. So we are checking for the popularity of each of our surveys within our app. Similarly, we have added a sort of a community blog feature where people can talk about their own about their own, about their surveys, about specific data about specific surveys. Generally, chat about the app. So let's say we talk about the again about the test survey, and let's say we talk about how this patient one just gave the patient one just gave the test survey. We posted this to our blog. So here we can see that we posted a new blog post talking about about test survey. Here we can see that the popularity of the which affects the popularity of, similar to how the other surveys affect the popularity, how general chatting about the surveys affects the affects the popularity of our survey. Another features that we've added is that the based on the course location of each of our users, the hospitals around our users are also shown on the map. So this map shows the hospitals around each of our users, all of our users. Next is the research section. Here we have provided a sort of a database for diseases, which we are fetching from a JSON repository where this data is stored, and we keep adding it based on as more and more diseases are discovered or general data about these diseases are known. We also added a news app, which shows using the news API and shows which can be used to search data about different topics, especially medical topics, and gives the user a platform to view and read about medical news and other news. So this was our app DocSvey, in which we've used blockchain technology for securely transferring data and creating and allowed users to create and take surveys and medical records and transfer these medical records on validation. We also added a communication feature and a community blog feature, allowing doctors to affect the popularity of their created surveys. So there are also map activities, get the general idea of the location of our users, of the number of users we have, of the diversity of the users of our community. There's also a research section which provides us about data about the diseases and all the diseases in the world. So we provided a sort of a disease database. A news section which provides using the news API, which provides data about the news, which provides general news items. Thank you.